Average IQ scores rose 30 points in the United States between 1932 and 1997. Since genes cannot change that fast, the Flynn effect proves that environmental factors can dramatically alter measured intelligence across generations. Yet the heritability of intelligence within generations is also high. The nature-nurture debate about intelligence has a clear resolution. Both are real and both matter, but they explain different things. The Minnesota study of twins reared apart followed identical twins who had been separated in infancy and raised in different families, testing them extensively in adulthood. Despite being raised apart, identical twins showed IQ correlations of approximately 0.70 to 0.75, nearly as high as identical twins raised together, whose correlations average about 0.86. Fraternal twins raised together show IQ correlations of only about 0.55. These comparisons yield heritability estimates of 50 to 70% for IQ in adult Western samples. Adoption studies provide convergent evidence for genetic influence on IQ. In the Texas Adoption Project and similar studies, adopted children's IQs were more strongly correlated with their biological mother's IQs, who they shared genes with but not environment, than with their adoptive mother's IQs, who they shared environment with but not genes. As adopted children age, the environmental influence of the adoptive home diminishes and the genetic influence increases. Adopted siblings become progressively less similar in IQ as they move into adulthood and out of the shared household environment. One of the most important nuances in intelligence heritability research is that heritability is not a fixed property of the trait. It varies with the environment. Heritability of IQ increases with age. It is moderate in childhood, higher in adolescence, and highest in adulthood, as people increasingly select and create environments consistent with their genetic propensities. More strikingly, Turkheimer and colleagues found that heritability of IQ approaches zero in impoverished families and is near normal in affluent families, suggesting that in poverty, environmental constraints dominate individual differences, while in more enriched environments, genetic differences express themselves more fully. James Flynn's documentation of rising IQ scores, approximately 3 points per decade in the United States and many other nations throughout the 20th century, produced one of the most significant findings in intelligence research. The 30-point rise over 65 years is enormous by any standard. It means that people considered average IQ today would have scored in the superior range by 1932 standards. Since heritability of IQ is substantial, Flynn argued that rising scores must reflect environmental changes that improved cognitive ability across populations. Multiple factors have been proposed to explain the Flynn effect, and the current consensus is that the rise is multiply-determined. Better childhood nutrition, particularly reduced iodine and lead exposure, directly benefits neural development. Longer schooling and exposure to abstract, logical reasoning develops the specific cognitive skills that IQ tests measure. Greater familiarity with the abstract, symbol-manipulating demands of standardized testing improves performance independent of underlying ability. Richer, more cognitively stimulating environments, more complex jobs, more diverse information sources may broadly enhance cognitive development. Several Scandinavian countries began showing declining IQ scores in the 1990s, a reverse Flynn effect, after decades of gains. Norway, Finland, Denmark, and Sweden all show this pattern in data from military conscription testing. Proposed explanations include the exhaustion of environmental improvements that drove earlier gains, changes in educational practices, dietary changes including increased consumption of ultra-processed foods, and increased screen time. The reversal is modest compared to the earlier rise and is not universal, but it suggests that the environmental gains fueling the 20th century rise have been partially offset by new environmental factors. Perhaps no topic in intelligence research is more politically sensitive or more frequently misunderstood than group differences in average IQ scores. Measured score gaps between racial groups in the United States have been well documented. The current scientific consensus, based on decades of research, is that these gaps reflect the cumulative effects of environmental factors, differential access to quality nutrition, healthcare, education, and cognitively stimulating environments, chronic stress from discrimination, stereotype threat effects, and historical policies that created lasting socioeconomic disparities, rather than genetic differences between racial groups. The strongest evidence against a genetic explanation for group IQ differences is the documented narrowing of the gap over time, which tracks changes in educational access, socioeconomic conditions, and the reduction of some environmental disadvantages rather than any change in the genetic composition of populations. Racial gaps in test scores narrowed substantially between 1970 and 1990, correlating with improvements in environmental conditions. They widened again in periods when socioeconomic inequality increased. These trends are exactly what an environmental explanation predicts and what a genetic explanation cannot account for. Intelligence is substantially heritable, yet IQ scores have risen 30 points in a single human lifetime. This paradox, high heritability and dramatic environmental change, is resolved by understanding that heritability describes variation within a generation, while environmental factors explain differences between generations and across socioeconomic conditions. Both nature and nurture are real, powerful, and inextricably intertwined.